Let's prove that the expression x to the 16th power minus x plus 1 is always positive for every real number x. I'm going to show you two different methods. So little in one, we start by trying to rewrite the expression so that we can show it is always larger than 0. A direct approach doesn't work. So we do a little trick. If we had something like x to the 16th power minus x to the 8th power plus 1/4, then that part could be written as a perfect square. So we force this piece to appear and then add the remaining terms so the expression does not change. After doing that, we can rewrite the whole expression as the square of x to the 8th power minus 1/2 plus x to the 8th power minus x plus 3/4. Now, we still have that leftover part, x to the 8th power minus x plus 3/4. So we apply the same idea again. We create the piece x to the 8th power minus x to the 4th power plus 1/4, which can again be written as a perfect square. Then we add what is needed to keep the expression unchanged. This gives us a new piece that can also be rewritten as a square. We continue the same procedure one more time. We create x to the 4th power minus x squared plus 1/4, which forms another perfect square, and then adjust the remaining terms. At this point, the expression is now written as the sum of several perfect squares. Since every square is always 0 or positive, the whole expression is at least 0. But we also need to show that it is never actually equal to 0. For the expression to be 0, every one of the 4 square pieces would have to be 0 at the same time. The last piece becomes 0 only when x equals 1/2. But when x equals 1/2, the other squared pieces do not become 0. So all 4 pieces can never be 0 simultaneously. That means the entire expression is never 0. So the expression is always strictly positive. Solution 2. Let's look at the inequality in another way. We rewrite it as x to the 16th power plus 1 is greater than x. To prove this, we compare the graphs of y equals x to the 16th power plus 1 and y equals x. If the graph of x to the 16th power plus 1 is always above the graph of x, then the inequality is always true. First, think about the graph of x to the 16th power plus 1. It is symmetric with respect to the vertical axis, and its shape is similar to the graph of x squared plus 1. When x equals 1, the value is 2, so we can sketch a rough shape. Next, we draw the graph of y equals x, which is a straight line through the origin and the point 1, 1. From the picture, it already looks like the curve of x to the 16th power plus 1 is always above the line y equals x. But we will check this carefully. We split the real numbers into 3 regions. First region, x is less than or equal to 0. In this region, x to the 16th power plus 1 is at least 1, and x is less than or equal to 0. So the expression on the left is greater than the expression on the right. Second region, x is between 0 and 1, including 1. In this region, the graph of x to the 16th power plus 1 is always above the height of 1, while the graph of y equals x stays below or equal to 1. So again, the inequality holds. Third region, x is greater than 1. Here we multiply both sides of the inequality by x to the 15th power. This number is positive, so the direction of the inequality stays the same. After multiplying, we get x is less than x to the 16th power, and clearly x to the 16th power is less than x to the 16th power plus 1. So we conclude that x is less than x to the 16th power plus 1. Since the inequality holds in all 3 regions, we have proved that the original expression is positive for every real number x. Final conclusion. So, Using either the algebraic method of rewriting the expression as a sum of squares or the graphical method of comparing two curves, we see that x to the 16th power minus x plus 1 is always positive for every real number x.